All right, the second video in section 6.1 is all about simplifying rational expressions. So we just talked about domain restrictions, remember where the denominator is going to equal 0. But now let's talk about if we have a rational expression, how can we reduce it or simplify it? A couple of different things you can look for. First, if all the terms have a GCF, a greatest common factor, then you can reduce each of those terms by dividing by that GCF. If there isn't a greatest common factor, then maybe try factoring the numerator and factoring the denominator so that you could reduce. If there isn't a GCF and you cannot factor, then maybe the problem just isn't simplifiable. Look at maybe just a simple fraction like 15 over 40. If I ask you to simplify or reduce, is there a factor, a greatest common factor of 15 and 40? So what can divide evenly into 15 and 40? And what's the biggest number that can divide evenly into 15 and 40? I'm thinking 5. So let's actually go through and divide the numerator and the denominator by 5, that greatest common factor. 5 goes into 15 3 times, and 5 goes into 40 8 times. Now, is there another greatest common factor between 3 and 8? Any number that divides into 3 and 8 at the same time? I can't think of any. So it looks like this would be the reduced or simplified version of 15 over 40. My reduced answer would be 3/8. We can do the same thing even if we have rational expressions, even if we have variables in the numerator and denominator. Let's try. Look at this next one. It says 2x squared over 4x. Let's look at our coefficients first. Is there a GCF of 2 and 4? And then let's look at our variables. Is there an x I can take out of both an x squared and an x? Let's go ahead and divide both the top and the bottom by a 2 and an x. That's my greatest common factor. If I divide this top one by a 2x, I end up getting just an x left. If I divide the denominator by a 2x, 4 divided by 2 is 2, and if I take out the x's, then I have left just an x over 2. That would be the simplified version of that rational expression. Let's do some more. Looking at example number 2, it's going to ask us to simplify. So you've got a couple of different rational expressions. They all look a little bit different. Some single term polynomials on top and bottom, monomials. Some we have multiple terms, and some we have multiple variables. Let's do each of these. On the first one, let's look for a GCF. Is there a GCF between 8 and 24? Is there a GCF out of x to the 4th and x to the 7th? What's the biggest amount you can divide into both of those? I'm going to divide then each of my terms, both the numerator and the denominator, by an 8 and an x to the 4th, making sure that you do every term in the numerator and every term in the denominator. 8 divided by 8 is 1. X to the 4th divided by x to the 4th is also 1. So my numerator actually looks like there's just a 1 left over. If I divide 24 by 8, I get 3. If I take x to the 7th and divide it by x to the 4th, remember your rules for exponents. When you divide, you really subtract the exponents. So I end up with x cubed in the denominator. So it looks like this would be my simplified version, 1 over 3x to the 3rd. All right, let's look at b. If you notice on b, we have a binomial on the top. There's actually 2 terms on the top and 1 term on the bottom. So a total of 3 terms, right? And so if I want to reduce or simplify, I need to find a greatest common factor between all 3 pieces, not just 2, but make sure you do it to every term. So what's the greatest common factor between 2, 4, and 8? What's the greatest common factor between x squared, x, and x to the 3rd? And what's the biggest amount of y's I can take out of y, y squared, and y cubed? Well, I'm going to divide everything by a greatest common factor of 2, x, and y. I can take out a 2 out of everybody, reduce everybody by 2. I can take an x out of each term, and I can take a y out of each term. That's the biggest amount I can take out of each term, all 3 of them. So let's divide all 3, 1, 2, 3 terms by a 2 and an x and a y. On the top, when I GCF or I take out my GCF of a 2xy, I end up with just an x minus a 2y. 2 divided by 2 is 1. If I have an x squared and I take out one of them, I have 1 left. I had a y, I took out the y, so I have no more y's left in that first term. Then I have a negative 4 divided by 2, which is negative 2. If I took out the x from my GCF and I took out one of the y's, I have 1 y left. So my numerator ends up being an x minus 2y. Or you can put a 1 in front of that x if you want to. Now my denominator, 8 divided by 2 is 4. If I started with x cubed and I divided by an x, I have an x squared left. If I started with a y cubed and took out another y, I have a y squared left. That should be my simplified version of this rational expression. I have no other number, no other letter or variable I can take out of all three terms. Now be careful. Please do not take out or think that you can reduce this 2 and the 4 because you can't take out a 2 from this term. You have to be able to take it out of all three in order to be able to take it out or simplify by it. So that would be my final answer. Let's look at C. Now be careful. If you look at C, I noticed 1, 2, 3, 4 different terms, right? And in order to be able to reduce or take out or divide by a GCF, I need to be able to take out a GCF between all 4 terms, not just a few of them. So is there a number you can take out of 6 and 12 and 7 and 14? I can't think of any. Now can you take out an x out of all 4 of those terms? It doesn't look like it. So if you can't take a number out of all of them, then you can't take out or divide by a GCF. If you can't take out an x from all of them, then you can't divide by a GCF. So if there is no GCF, then what other techniques do we have for simplifying rationals? Well, remember our second step here. If there is no GCF, then maybe we can look to try to factor before we reduce. So look back at that problem and look at your numerator. If I asked you to factor this, what do you notice about both of those terms in my numerator? It looks like they have a GCF, right? Can I factor out a 6 from both the 6x and the 12? If I take out a 6, then that leaves me with an x minus 2, right? Just like I did back in chapter 5. Now do the same thing with your denominator. What can you take out of a 7x minus 14? It looks like we can take out a 7, leaving me with an x minus 2. So if you notice on the top, I have 2 things being multiplied, 2 factors, and on the denominator I have 2 factors. If any of those factors are the same on top and bottom, then I can actually reduce by a factor of x minus 2. You can think about it as dividing both the top and the bottom by an x minus 2 if you'd like to. As long as there's no plus or minus sign connecting and they're just being multiplied, then I can reduce an x minus 1 from the top and the bottom, leaving me with just a 6 over 7. So 6/7 is a lot more simplified than my original rational expression. So if there is no GCF of everybody, then maybe you can factor the top, maybe you can factor the bottom, and then find a common factor to be able to reduce it by. All right, let's look at a few more of these. All right, if you look at D, I noticed again 1, 2, 3, 4 different terms. Is there a GCF between all 4 of these terms? Do you notice a number that can be taken out or divide into 18, 6, 6, and 15? And can you take out a t from all of those different terms? If you can, let's divide every single term, all 4, by the GCF of 3 and t. When I do that, when I divide every term by 3t, that turns my numerator into a 6t plus 2. I divided each piece by 3t. I'm also going to do the same thing with the denominator. So let's divide each term in the denominator by 3t. I ended up getting a 2t plus 5. All right, can we factor any more or reduce any more? Maybe you notice that the numerator has a GCF of a 2. If you take out that 2 from just the numerator, you would have left a 3t plus 1, right? Now my denominator, though, doesn't really have a GCF. There is no GCF between 2t and a 5, so I would just have to leave it. Now be careful. I cannot reduce these 2's because this 2 down here is connected with the t plus 5. Because it's not being multiplied by the whole thing, it's not a single factor of, we can't reduce this one any more than it already is. So either this orange one would be an answer, or you can do the pink one. It's just a little more factored, but I can't simplify it any more than it already is. All right, let's look at E. Wow, I notice a lot of different terms on this one. I notice 1, 2, 3, 4, 5. Now if I look at all 5 terms, is there a GCF between all 5 terms, something I can take out of everything? I don't think so. So if there is no GCF of everything, let's try to factor. Let's try to factor the numerator, and let's try to factor the denominator. It looks like the numerator is a basic factor. So what numbers multiply to 2 that add to 3? What kind of factoring does it look like the denominator is? Oh, that looks like a difference of squares, right? So we should be able to factor that into two conjugate binomials. All right. When I factored the top, I ended up factoring into an x plus 2 and an x plus 1. When I factored the denominator, I factored it into x minus 1 and x plus 1. Now I have 4 factors. I have 2 factors on top being multiplied and 2 factors on bottom being multiplied. And I notice that I have a common factor. I have an x plus 1 on the top and an x plus 1 on the bottom that I can reduce. That leaves me then with an x plus 2 on the top and an x minus 1 on the bottom. No other common factors that I can reduce. I can't reduce those x's because they're connected with a plus or minus sign. So I always try to keep my parentheses around it to show that they're being protected, right? This is one factor connected with a plus sign, and this is another factor connected with a minus sign. And if I can't reduce the whole factor, then I can't reduce. So that would be my final answer. So with or without the parentheses would be okay. Let's look at F. 1, 2, 3, 4, 5. I see 2 terms on the top and 3 terms on the bottom, 5 different terms. I looked for a GCF of all 5 terms and I couldn't find one. I couldn't find anything I could take out or simplify for all 5. So let's try our factoring technique. What can I factor out of that numerator? It looks like I can factor out a GCF in just the numerator, and I can take out an x and put it in front, leaving my x minus 5 next to it, being multiplied factors. On the denominator, it looks like that's a basic factor, so numbers that multiply to negative 10 that add to negative 3. So I factored it into x minus 5 and x plus 2. Now, if you notice, I have 2 factors. They're just being multiplied on the top, and 2 factors being multiplied on the bottom. And is there any common factor that I can reduce by? Well, it looks like the numerator and the denominator both have an x minus 5. So as long as they can take that whole chunk off, I can divide each one by an x minus 5. What does that leave on the top? And what does that leave on the bottom? Well, it looks like your numerator is just an x now, and your denominator is the x plus 2. Again, be careful. You can't take the x's away because you can't take an x out of all 3 terms. And again, if it helps you, keep those parentheses around your x plus 2 so you can see that it's protected. And if you can't reduce by a whole nother x plus 2 on the top, then you can't reduce just the pieces. So that would be my final answer. Again, with or without the parentheses if you want to. Just be careful not to reduce those x's because you have 3 terms and they don't all have x's. You can't reduce some and not all of them. Okay? All right, so here's where the caution comes in. Like I said, you can't reduce or just take off the x's here. Because they're separated, or connected I should say, by a plus or minus sign, if you can't reduce the whole group, then you can't reduce. Or if you can't reduce an x out of all 4 terms, then you can't reduce an x. Okay, so be careful with that. Another common thing I see students do is on this middle one trying to reduce by 5. Remember, if there's 3 terms and you're trying to reduce by 5, then you better be able to reduce all 3 terms by 5. Everybody, a greatest common factor. And since this first term doesn't have a 5, then you can't reduce by 5. Okay? All right. In this last one, same idea. Some students try to reduce the 6 and the 4, so be careful with that. You can't reduce just one term at a time, okay? So just a little caution there, being careful not to reduce pieces that you're not allowed. If there's a GCF in all of the terms, then you can take it out. If not, then you need to focus on the numerator separately and the denominator separately, and then see if there's a common factor that you can reduce by. Practice simplifying, as we're going to get a little more complicated here in the next video.